Okay, so this is section 6.7, quadratic equations and problem solving. So your favorite thing, word problems. All right, so on this first one, it says an object is thrown upward from the top of a 144-foot building with an initial velocity of 128 feet per second. The height h of the object after t seconds is given by the quadratic equation. So essentially you're reading that and you're like, what? So what we want to identify is this equation. And the question says, when will the object hit the ground? So one thing I want to understand is basically this is actually like a real function and form that's used in physics because it's real. Okay, so this is something that relates to real life. Like if you throw something off the top of the building, how long will it take to hit the ground? Like that's literally, it's like a science project. All right, so we have this equation, h equals negative 16t squared plus 128t plus 144. H is the height of the object. So if we want to know when it hits the ground, 0 is the ground. So basically on this equation, you're going to substitute in 0 for the h. All right, so anytime you see that type of problem and it tells you you're looking for how long it takes it to hit the ground is always considered 0. There is no height at the bottom, at the ground, right? All right, that's what makes it the ground. So we set the equation equal to 0, and then we're trying to find the time it took to get to the ground. So we're looking for t. So we have to solve this equation. And so we have to get into our mindset of solving, which means trying to isolate the variable, right? So we got to go through our process. So if I'm trying to isolate the variable, when I look at this equation, what do I know? I know that there's an exponent of a 2, which means the only way that I know how to solve it is to factor it. And so you have to make sure that before you work it, you have to know whether you have to factor to solve for that variable or whether you can just begin to isolate by moving terms. So because I see that there's a squared there, I know that I can only solve this by factoring. So now I'm getting into my factor mode. So it's already in descending order. I look to see if there's a greatest common factor. So I know it's going to be something negative that comes out. And let's see, I think if we use 16, it'll probably factor out of everybody. So 128 divided by 16, what's that? 8. So minus 8t, because remember, I'm dividing out the negative. Remember, if the GCF should always be negative if the leading coefficient is negative, right? And then 144 divided by 16 gives us a negative 9. All right, so we're taking this t squared minus 8t minus 9, and we're factoring that. So my a is 1, so I'm just going to do 2 sets of parentheses. So factors of 9, that'll give me an 8. So 9 and 1, negative 9 plus 1. So t minus 9 equals 0. T plus 1 equals 0, right? So we factor it. Once we factor it, you set each factor individually equal to 0, and you solve for each t, right? Because now I have a variable that doesn't have an exponent other than 1. So I know how to solve for that. I just isolate the variable to one side. So t minus 9, I add 9 to both sides. So t equals 9. T plus 1 equals 0. I subtract 1 from both sides. So t equals negative 1. And so I have this as my answer. What am I looking for? This is a word problem. I'm looking for how long it takes the object to hit the ground. Well, timing is not negative. Time can't be negative. So the only answer is 9. So that would be 9 seconds. Okay? So when you have these problem-solving problems, one of your answers is going to come out negative. It's a real-world situation. It's not going to be negative. So you use the other answer. All right, let's do the next one. All right, so number 2 is just like number 1, essentially. So we're looking for when the object hits the ground. So we have this equation, h equals negative 16t squared plus 324. So we set h equal to 0. And I'm going to rewrite it so I can have my variable on the left. So I'm going to factor this. So it's in descending order. I don't think there's a GCF there. So, oh no. All right. So the GCF is not 16. The GCF is going to be negative 4. So I will get 4t squared minus 81 equals 0. All right. So I'm looking at this binomial here, 4t squared minus 81. So I've already factored out the greatest common factor. So when I see this binomial, I see it's a difference, right? Okay, so difference of two perfect squares. 4 is a perfect square, 81 is a perfect square. So I know this is the difference of two squares. So I do my two sets of parentheses, 2t, 2t. 81 is going to be 9 and 9. 1's plus, 1 minus. Bring the negative 4 down, equals 0. So then we set our factors equal to 0. Negative 4 equal to 0 means nothing. Okay, because there's no variable component. So then 2t plus 9 equals 0. 2t minus 9 equals 0. So when we do this one, 2t equals negative 9, t equals negative 9 over 2. Well, we know that's not it. 2t equals 9, t equals 9 over 2. All right, now, when you look at my math lab, it says type as an integer or a decimal. Remember what I told you. You always leave your answer on the solve as a fraction in lowest term unless you're doing a word problem or an application problem, and that is the case where we use a decimal. So we are trying to identify the amount of time that it takes for this object to hit the ground. 9 over 2 makes no sense to us because that is not how we operate. So 9 divided by 2 gives us 4.5 seconds. And so that's what we're looking for the answer. All right, so watch that when you're doing it on my math lab. All right, let's do the next one. All right, so on number 3, if the cost C for manufacturing X units of some product is given by C equals X squared minus 25X plus 60, find the number of units manufactured at a cost of $10,410. So essentially, we have this equation here. So C equals X squared minus 25X plus 60. So they're telling us the cost to manufacture this item is $10,410. So we have to figure out how many units was produced by this, right? So it cost them this amount of money. So we want to know, well, how many units were they producing? And so we would do that by what? Solving for X, because X represents the number of units. So when I look at this equation, X squared minus 25X plus 60 equals 10,410. I'm trying to solve this equation. So we have to be in our mindset, again, solving, isolating a variable. Okay, so when I do that, I need to look at how I can isolate the variable. Because I have an X squared here, I know that I can't just isolate the variable. I first have to factor this equation. All right, so then we have to know our steps for factoring, solving by factoring. So first of all, it has to be in descending order and it must equal 0. This does not equal 0, so we have to make this equal to 0. So to make this equal to 0, we would subtract the 10,410 on both sides. So X squared minus 25X minus 10,350 equals 0. So we are looking for factors of 10,350 that can give us 25. Yes, it's huge. That's why we have a calculator. So what we need to do is let's divide by big numbers. So let's see, 25, 14, no. 150, 69. I'm gonna pause this. Okay, it took me forever. But I finally found a pair. So 115 and 90. So this problem is going to be some big number. So you just got to like try to stick through it and just keep trying numbers. And because it's like 5 digits, you know, you're going to need a 3-digit number and another 2-digit number. So you just got to try and just keep trying numbers. It ended in 0. So probably should have just kept dividing by tens, but that's my fault. All right, so x and x, and then 115 and 90. So negative and plus. So x minus 115 equals 0. X plus 90 equals 0. So when we solve this, we would get x equals what? Positive 115. And then x equals a negative 90. We know that this x equals 115 units would be the answer because you can have negative units. Okay? All right, number 4. So number 4 deals with right triangles. So what we want to know about right triangles is we want to know the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, so when you have a right triangle, you have the right angle, which is usually always identified with that little square box. The 90-degree angle is what it is. All right, so the side of the triangle that is opposite from the 90-degree angle is always the hypotenuse, or your C. Okay, so the slanted side. So the slanted side is always the C, and the slanted side is always going to be opposite from the 90-degree angle, and then the other two legs are just A and B. Okay. So we have this right triangle here on number 4. The hypotenuse of a right triangle is 8 centimeters longer than the longer leg. The shorter leg is 17 centimeters shorter than the longer leg. Find the length of the longer leg of the triangle. So luckily, the picture's there. They already set up the expressions for you for each one. So unlike your beam problem in chapter 2, you don't have to set up your own expressions, right, and make the equation. You just have to make the equation here. So you have an A, a B, and a C. So you use the Pythagorean theorem when you're trying to solve sides for the right triangle. So it doesn't matter who you put in for A and B. The only one that matters is who C is, right? Because C has to be the hypotenuse. So x minus 17 squared plus x squared equals x plus 8 squared. So I just substituted directly into my Pythagorean theorem. A squared plus b squared equals c squared. So I just substituted. The only thing I know is definite is who C is. Who you put in for A and B, it doesn't matter. Okay? So now we're going to work through this problem so that we can solve for x. So first we got to multiply all of this out. All right? Don't be lazy. You got to write it out. X minus 17 times x minus 17. All right, so I'm going to multiply all this out. So x squared 17 times 17 nope 64. All right, So we got to go through and simplify as much as possible. Oh, I could have simplified that. That's okay. So 2x squared minus 34x plus 289 equals x squared plus 16x plus 64. All right, so I've simplified as much as possible on the left side and as much as possible on the right side. So remember, we're trying to solve this. Well, I have exponents of to the second power, so I know I'm going to have to factor. So in order to solve by factoring, you have to get all of your terms on one side and make the equation equal to 0. So that's what I'm going to do. I'm going to move each term on the right side to the left side. Okay? I'm going to pause it and do it. All right, so I subtracted x squared minus 17x minus 64 on both sides. And so when I combine my like terms, I get x squared minus 50x plus 25 equal to 0. So we're factoring. So I need factors of 25. That'll give me 50. So I have negative 45 and negative 5 equal to 0. So x minus 45 equals 0, x minus 5 equals 0. So we get x equals 45 and x equals 5. So we're going to substitute those in. So if we use x equal to 5, if we use x equal to 5, if you look at what you have here, if you use the x equal to 5, then you wouldn't be able to have a negative 17. See, 5 minus 17, that wouldn't work because this side is 17 shorter than that length. And so you couldn't have a negative side. So 5 can't be the option. So 45 must be the option. And so you would substitute in your values. And so x is 45. And then 45 minus 17. 28. And then 45 plus 8. So you would have had all your sides to your triangle. The length of the longer of the legs is 45. So x is 45. And then I just found the other sides as well. So you have 45, 28, and then your hypotenuse is 53. All right? And that's how you use the Pythagorean theorem. And that's problem solving.